Thank you. Okay, so welcome everyone. This is session 11. We're about to finish this course. So yeah, we're excited, sorry. Yeah, so we've reached a truly advanced point in our journey of building the chatbot. If you think back to the previous sessions, we've created a system that is accurate, fair, secure, transparent, and efficient at on an industrial scale. So in many ways, we've built a near perfect machine, a chatbot that works correctly, that answers great answers, and that represents the best knowledge we had at the moment that we launched this chatbot. But there is a hidden danger that we should really be talking about, which is this machine, which is the chatbot that we have built and developed. It is frozen in time. It reflects our knowledge on the day of launch and not after that, only the day of launch. So the problem here is that the word itself is not frozen. Everything keeps changing, language evolves, new products come out, company policies get updated, etc. So if the chatbot stays the same while the word moves forward, it slowly becomes outdated, just as we talked before about the data sets. So the chatbot itself becomes outdated, and eventually it becomes dumber than the users themselves. So it becomes useless. Let me give you an example here. Imagine a customer support chatbot for a specific bank. When it launched, let's say in 2024, it was perfect. But 1 year later, the bank introduces new features, new payment methods, new policies, new things. And the way people speak online also changed. But the chatbot, it's still living in 2024. So if a customer asks, hey, how do I activate Apple Pay? And the chatbot answers, sorry, that service is not available, even though it has been available for 6 months. This is exactly what happens to most chatbots in the world. They start strong and then slowly decline because they don't evolve. And that's why today's session is really important. We are shifting from evaluating a snapshot, which is a static picture of the system, to evaluating the full movie of how it evolves over the time. So today we treat the chatbot as a digital living organism, one that must grow and improve and learn from users and adapt as well. Is the word of continual learning and active learning. The continual learning is which means learning continually over the time, and active learning is learning smartly from real interactions. And this is the real challenge that separates a beginner chatbot from a long-lasting, truly intelligent one. And the features that we're about to talk about. Okay, so let's be honest. This whole idea of a chatbot that learns from users, it sounds amazing. It sounds like the dream, like we solved the problem. But which is the more people talk to it, the smarter it gets. But in reality, this idea is full of danger. We don't have to look far for proof. We've got a proof back in 2016. Microsoft State Chatbot, if anyone recalls it, it was released by Microsoft as a Twitter chatbot. It was released for only a few hours, and because it was learning directly from whatever people told it, like if someone is interacting with it at the moment, it gets the behavior and the language, the language and the way the user is talking, to the chatbot, it learns it at the moment, like quickly. So because of that, it quickly started producing offensive and abusive content because you don't really control what people can say to it. So it went from hello world, which is the static programming like sentence for most of programming projects, to an unacceptable behavior, completely unacceptable behavior, which is in less than a day. So this is what happens when learning is not controlled. It's just being randomized. The chatbot is learning from anybody without any like rules or someone controlling the things that the users are saying, etc. So continual learning can go wrong in two major ways. The first one is concept drift. The model starts drifting away from its original purpose. For example, a customer support bot suddenly starts giving opinions or using slang because users keep writing informally, etc. It loses the professional tone, and it forgets what it was made to do. Also, we've got catastrophic forgetting. The model learns new information but forgets older knowledge in the process of relearning. So it's like learning a new language and suddenly not remembering the native or your native language anymore. So in right now, when we talk about evaluating a chatbot's ability to learn, we're not just asking, did it improve? We're asking a much more important and specific question. Is the learning process stable and safe and controlled, and it gets the good output, the correct output that we're aiming for. So today we're going to break down what continual learning really means in the context of a chatbot. Also, we will define the criteria that we use to measure whether the system can learn from its mistake without breaking itself. We will look at how to evaluate the entire feedback loop, how feedback from users and internal evaluators can be transformed into clean and high quality training data. Also, we've talked about this before in session 7, if you recall. Also, we will explore techniques like active learning, where the chatbot is smart enough to say, I'm not sure. It doesn't just give you any information. It says, I'm not sure about this answer, and instead of hallucinating or whatever. So maybe also the system can raise a flag in some like deeply not or like uncertain or high impact cases, like if someone is talking about sensitive subjects like suicide thoughts or etc. It can have this flag that it could be traced back to the person who is talking to the chatbot. Okay, so think of this whole scenario or this whole process that we're about to deeply get into as building the chatbot's immune system, a system that allows the chatbot adapt and grow and also stay healthy without absorbing the bad bacteria or harmful data, and also without forgetting any who it really is. Okay, so our goal, in short, is to design and evaluate mechanisms that guarantee one simple truth, which is tomorrow's chatbot should always be better than today's. Okay, so before we go deeper, let's define what we actually mean by continual learning. A lot of people think continual learning simply means, we retrain the model every once in a while, but that's not it at all. Continual learning is a structured and intentional approach where the model is updated bit by bit, learning new information without needing a full retrain, and most importantly, without forgetting what it already knows. So why do we even need continual learning? Let's break this into four simple reasons. First one, concept drift. So the word changes, we said that, and the language does. And a word that meant one thing a word that meant one thing 5 years ago might mean something totally different today, or maybe a slang word that has come up to the surface. So let me give you a good example here. Before 2019, if someone said Corona, most people thought of a beer brand or a city or something. After 2019, it meant something completely different. If someone said Corona, we all could relate to that virus that hit the world. So a chatbot that doesn't adapt to like these shifts becomes outdated, or even worse, it becomes confusing. So that's the concept drift. Also, we've got user personalization. Every user is different. Some people like short and direct answers, some like detailed explanations, and some people always ask about the same product or topic. So a good chatbot should learn these patterns and adjust for each person, each user aside or apart. For example, if a user always shops for gaming accessories, the bot should naturally prioritize that category in its recommendations. Um, so continual learning helps the chatbot build this personal memory for each user. Also, we've got domain shift. The word of products and services and regulations and policies is consistently changing. Especially big companies, they change their policies every 3 months or less. So also new phone models come out, return policies change. So the word isn't static. If the chatbot doesn't keep up, it will start giving outdated or incorrect answers, and it results to users' unsatisfaction, and they lose trust in this chatbot. Also, we've got, or the final one is resource efficiency, which is retraining a huge model from scratch every time something changes. It is instantly expensive. So, like, it costs time, money, and enormous computational resources. We've previously talked about it in the previous session when we talked about the full training process, where it really costs a lot. It costs GPUs, and also TPUs. So it's just a lot to retrain the full process of training the model. So continual learning is a smarter approach and an update, to update the model in small targeted steps instead of rebuilding the entire model again and again each time. So in technical terms, this is called fine-tuning, which we don't really play with the core itself from the model. We just go around the bushes to recreate or to give it new information to learn from. So in summary, continual learning is how we help the chatbot to grow and adapt and stay relevant. Okay, so we understand that continual learning is let's talk about that let's talk about it as the first step. Now let's understand the challenges of this continual learning that makes it difficult to like um, to follow it. um, Honestly, because continual learning is powerful, it's not easy to get it right. Like there are multiple challenges. Let's talk about three of them. The first one is catastrophic forgetting. This is the classic problem when we train the model on new information. Let's call it task B, for example. The model may accidentally forget how to handle task A, things that it already knows. So it's like studying for a new exam and suddenly forgetting half of last semester's material. Um, for example, imagine if we update a chatbot with new information about like latest phone models and etc. If we're not careful enough, the model might suddenly struggle to answer questions about older models that it used to know before this whole I'm sorry, the fine tuning step. And why does this happen? Because the model's internal ways adjust to fit the new data, and this sometimes overrides the older knowledge that it used to know. Also, we've got the stability plasticity dilemma. This is the heart of continual learning. The model needs to be both plastic and stable, which is enough to plastic is enough to learn new information and stable enough to not forget what it already knows. So if the model is too plastic, the model forgets everything old, and if it is too stable, the model can't learn anything new. It's like teaching a person who takes notes on a whiteboard. I'm sorry, it's teaching. It's like teaching someone who takes notes on a whiteboard. If the board is too easy to erase, the old notes it disappears. If the board is permanent, is permanent marker only, nothing new can be written on this board. So continual learning is about finding the perfect balance between these two. Okay. We've got also the quality of feedback data. Not all data should be learned from the users or learning learning directly from the interactions of the users. This is extremely dangerous. Users make mistakes and they give conflicting information, they give false information, and even worse, they may intentionally try to break the system. So if we feed that directly into the model, we get bias and toxicity, and wrong facts and corrupted behaviors. So this is why we really need strong filtering and also validation processes through relearning the model. Um, so there are also there are two main approaches that we use in real world for the paradigms of continual learning. The first one is online learning. The model is updated after every single user interaction. This is actually extremely risky for large models because one bad interaction can corrupt the whole system. So it's rarely used for industrial scale AIs. But the second one, which is mini batch learning, this is the most practical and widely used one. When the developers or like the creators of Chatbot, they collect new data over the time, then update the model periodically, which is like maybe daily, maybe weekly, maybe monthly. This actually allows for careful filtering and validation for safety checks. So it's the perfect balance between stability and adaptability. Okay, so let's move on to the next slide. Okay. So when a system keeps changing and improving over the time, evaluating it becomes a different challenge. We can't rely on a single accuracy score that has been taken at one moment. We need a metric that reflects performance across time, something that understand time data. And like knows how to how to evaluate the data at each certain moment in the time. So let's break these metrics. We've got three groups of these metrics. The first one is cumulative performance metrics. These ones, they show how the model behaves across the entire lifespan, not just today. Average accuracy over time is instead of checking accuracy at single time, we track accuracy across multiple time periods. This tells us whether the model maintains strong performance as it learns new things. So this is the average accuracy. Um, let me give you an example. If a chatbot that starts at 80% accuracy, if it drops down to 70% after a risky update, then climbs to 88% after refinement, the average over time gives us a much clearer picture of its overall learning journey. Also, we've got improvement rate. This measures how quickly the model improves when exposed to new tasks. So some models adapt fast, others slowly. A high improvement rate means the system is learning efficiently from the new data. The second one is metrics for measuring forgetting. Continual learning is not only about gaining new knowledge, it's about keeping the old ones as well. So after training the model on a new task, which we before related to, let's say task B, we measure how much its performance on an older task, which is task A, how much it decreased after the new learning. If task A accuracy drops significantly, that's a catastrophic forgetting. Our goal here is to keep BWF, which is backward forgetting, as low as possible. Also, we've got remembering. This is simply the inverse of backward forgetting, which is remembering equals 1 minus BWF. The higher this value is, the better the model preserves what it previously learned. The third one is metrics for measuring knowledge transfer. So these ones, they show whether the learning one task helps with another. So let's talk about forward transfer, which is short for we can say it as FWT. This asks, does learning task A help the model perform better on task B before it has been trained on task B? So if the answer is yes here, the model is demonstrating true generalization. It's not just memorizing, it's leveraging what it knows to understand new tasks even faster. So these metrics, they give us the full picture of how continual learning systems evolves. and how well it improves, also how well it remembers, and how well it transfers the knowledge to new domains. Okay, let's go move on for the next slide. So to evaluate a system that learns continuously, we simulate how it would behave as it encounters new information over time. Instead of giving the model one big data set all at once, we break it into the data, we break it into a sequence of tasks. Let's say T1, T2, T3, and so on. So this approach lets us observe how it learns and how it forgets and how it adapts. So let's talk about the process. Step one, which is training the model on task T1. We start simple. The model is trained on the first task and we record the performance. Let's call that score A1. This gives us the baseline, how well the model performs immediately after learning T1. And then in step two, we train the model on task two. The model learns how and measures two things over here. The first one is A2 and the second one is A1. I'm sorry. The A2 it measures the performance on the new task, and A1 is the performance on the old task after learning something new. So it's not just A1, it's A1 dash or A1 comma. So this second measure is crucial because it shows whether the model forgot anything from T1 and if it's learning well from T2. Yeah, so the step three is to calculate the forgetting. Once we have A1 and A1 dash, we can measure how much the model has forgotten. So it's forgetting equals A1 minus A1 dash. The final step, step four, which is to repeat with T3 and T4 and beyond. So we continue this process with task 3 and task 4 and so on till we finish the whole data set. So each time we train on a new task, we test on all previous tasks as well and calculate improvements and forgetting in this step. And finally, we plot these metrics across time and look for the whole picture and see where it went wrong and where it was correctly like developed. So this gives us the whole picture of the system's evaluation across time, not just one single moment. Okay. So let's talk about the methodologies for evaluating the human in the loop. I will tell you about something about this human in the loop thing. So continual learning isn't something we can hand over completely to automation. For the system to stay like safe and reliable, humans must have some interaction over here. Humans must be and must remain in the loop, guiding and correcting and validating what the model learns. And because humans they play a key role, we also need a way to evaluate how effective this feedback loop actually is. So let's look at the two main sectors, the main two sources of feedback and how we evaluate each one. Okay, so the first one is explicit feedback. This is the feedback users give directly, the things that they intentionally tell us. If an example is given, maybe it's a thumbs up or a thumbs down way of interacting, or maybe a star rating, maybe small surveys like was this helpful, rate this from scale 1 to 10, etc. So since the user has to take an action, the system needs to make giving feedback as smooth as and natural as possible and as short as possible. So what do we evaluate over here? The first thing we ask is the interface simple and clear? If users can't find the button or don't understand what it means, they won't actually respond. The second question we ask is what's the response rate? If only 1% of users leave feedback, we're not getting enough signal to learn from. Also, we ask, are we asking the right questions? Was this helpful? Is this vague, or is it a correct way to collect feedback? More useful questions can be, was the answer correct? Was it complete? Was it clear? Good explicit feedback gives us highly quality and targeted data that the model can learn from without needing to play with this feedback data and like clean it as much. So the way we collect the feedback is really important. Also, we've got implicit feedback. Unlike explicit feedback, this type is inferred from user behavior rather than directly stated. So, for example, did the user suddenly end the conversation after a certain answer? Did they rephrase their question multiple times because they didn't get what they wanted, etc.? So, these behaviors, they carry strong signals. Even if the user never clicks a button, we can see the way it interacted with the chatbot and get the feedback from this process. So how do we evaluate this mechanism? Uh, we ask two questions. How accurate are our model at interpreting these behaviors? And also, can we validate these automatic interpretations? So if implicit and explicit feedback align, we know the system is correctly reading user behavior. If they don't, we need to adjust the detection models before using the data for learning, and also maybe cleaning it and getting it through multiple processes before we get it into the model itself. Okay. So once we collect feedback from users, whether explicit or implicit, we can just dump it directly, as I said, to the training pipeline. Raw feedback is messy, biased, and sometimes completely unusable. That's why all feedback must pass through a careful and human-controlled curation and annotation processing or process. Think of it as a purification stage. The data enters noisy and comes out clean, structured, and trustworthy as well. So yeah, let's walk through what it happens. Let's walk through the pipeline. So first of all, we've got filtering. This is the a simple task. I'm sorry, a simple step, but extremely important. We remove anything that cannot be used in the data, like spam or random messages or abusive or toxic content, etc. A chatbot shouldn't learn from a user saying you are dumb or lol, I don't know, or anything. So everything goes through a strict filtering layer. And the second one is to annotate. After filtering, human annotators step in, they step in to correct and clarify the data. Their job is to identify errors the chatbot made and to assign the correct intent when the bot misunderstood. For example, if a user asked for a refund policy and the bot answered with shipping options, The annotator labels the correct intent so the system can learn properly from this mistake. So how do we evaluate this step? There are two things that we look at. The first one is interface efficiency. And the second one is inter-annotator agreement, and the last one is resulting data query. So quality, I'm sorry. So yeah, so interface efficiency. What is this? We can ask one question here. Is the annotation tool easy for annotators to use? If the interface is slow or confusing, the quality of the data drops, and also the speed does. So a good annotation tool means fewer mistakes, faster turnarounds, and lower cognitive load for annotators. The second one, the inter-annotator agreement. We also check if different annotators are consistent. If two experts see the same sample, do they label it the same way, or do they follow the same rules? This is measured using statistics like Cohen's kappa, where a low agreement score means the guidelines are unclear, or maybe it means the task is ambiguous. And high agreement means the team is aligned and the labels are reliable. The last thing is, I'm sorry. So let's talk about. I didn't talk about the verify part. Let me go through it quick. So before any new knowledge is added to the system, it must be verified. So this includes fact checking, especially for information that will be added to the knowledge base. And let's go back. So the data quality at the end of the pipeline, the question here is simple. Does the curated data meet the high quality standards that we defined in session 7? Only if the answer is yes. Does the data move into training? This is how we ensure the system grows safely without absorbing noise or bias or misinformation. Okay. So, evaluating active learning strategies. Let's move into active learning, which is basically a smart way to save time and money when training a chatbot. Instead of having humans that review every single conversation, the model tries to be clever. It only sends us the examples it's struggling with the most. So think of it like a student who says, I know chapter 1 and 2, but chapter 3, I really need help there. So the teacher focuses on chapter 3. That's the annotators over here. That's exactly what active learning means. Where the idea here is that the chatbot scans over all conversations and asks itself, where was I least confident in my answer, and where could I have made a mistake? So those confusing or uncertain cases are sent to human annotators first. This way, we spend our human expert time on the examples that matters the most, not the easy ones. So let's talk about querying strategies. There are several strategies for deciding which examples the model should send to human. The first one is uncertainty sampling. Here, the model picks the conversations where it's unsure. For example, if the model predicts an intent with 55% confidence, that's a red flag. It's really close to labeling it another thing. So a good example Here, if a user asks, can you fix my bill? The model isn't sure it means billing issue or technical support or account update, so it sends this one to a human first. Um, Also, we've got a query by committee. So here we don't use just one model, we use a committee of models. If they all agree, perfect. But if they heavily disagree, something is unclear, so we need a human over here. Also, the last one is expected error reduction. This one is a bit more advanced. The model asks which example, if a human labels it, will reduce my future mistakes the most. So it's like prioritizing the training questions that will have the biggest and long-term benefits on its learning strategies. So if I give you an example here, if a complex customer complaint that touches that touches multiple topics, um, it might improve the model's performance across many categories over here. So it becomes highly priority to give to the humans annotators, of course. Okay, so now that we understand what active learning is, the next question is, how do we know if it actually works? So to evaluate it, we mainly look at efficiency, meaning if we give the model the same amount of human labeled data, does active learning give us better performance than just picking random examples? So let's talk about this one. First is efficiency. Think of it like this. Imagine that we have a budget to annotate 1,000 examples or conversations. We try two approaches here: the random sampling and the active learning. If we chose the random sampling, we annotate 1,000 random conversations, and the active learning, we annotate 1,000 carefully selected conversation that the model is unsure about. So we compare which model improved more and which one learned faster. In real projects, after active learning almost always wins because we're focusing on the hard cases, not just wasting time on easy ones. Also, we've got performance versus budget curve. To visualize this, teams usually draw a curve that shows on the x-axis the number of labeled examples and on the y-axis the model's accuracy. And a good active learning strategy will produce a curve that rises faster. That rises faster and reaches high accuracy with fewer labeled examples and clearly outperform the random sampling curve, of course. So this helps teams justify the cost of annotation and show how much time they are actually saving. Okay, so let's talk about evaluating the ability to remember and generalize context. So learning isn't only about knowing facts. Chatbots also need to remember context and understand conversations as they evolve. So this includes both short-term memory within the same chat and long-term memory across different sessions. So short-term memory or short-term contextual memory, here we test if the chatbot can remember details during a single conversation. So if a user said, I want to book a flight to London, then the bot asked or answered, sure, when? The user then says, next week. The bot should now respond with, okay, searching for flights. And not asking, oh, sorry, I did not, or not saying, sorry, I did not understand that, or anything else. So evaluation question here is, does the bot remember the destination, which is London, and does it remember the date, which is next week, or does it forget halfway through the conversation? Also, we've got the long-term memory, which is about personalization. So this is about remembering really important information about the users themselves across multiple sessions, like real users expect. So if a user tells a bot, "I am vegetarian," then a week later asks for recommendation for a restaurant, the bot should not suggest a steakhouse or something that has meat. It should remember the preference and adapt recommendations through it. And also we have a privacy evaluation, which we previously talked about. Uh, with long-term memory, with long-term memory, it comes responsibility. So we need to evaluate how are user preferences stored. Are they encrypted? The chatbot doesn't just like throw anyone's personal information across any other users like conversation. And does the user have the right to view and update and also delete these informations? So the idea is to the personalization must never compromise privacy over here. Okay. So, launching a chatbot is not the finish line, it's the starting point, actually. A real world system must continually evolve and adapt and improve. And in this session, we focused on what it takes to manage this ongoing transformation in a safe and structured way. So, we examined how continual learning turns a static model into a system that grows over time. This powers comes with risk. The model can forget things, it can drift. So if not carefully guided, it can be really bad. So to address this, we introduced a dynamic evaluation framework that looks beyond one-time accuracy and also incorporate metrics such as the backward forgetting and the forward transfer. So these measures, they help us understand not only whether the model learns, but whether it learns responsibly. And then we moved to the human side of the loop. The safe learning depends highly on humans when collecting feedback and curating it and also annotating it with clarity and consistency. We evaluated the effectiveness of these processes from the design of feedback mechanisms to the reliability of human annotations. So active learning actually added another layer of intelligence to the system. Instead of waiting passively for labeled data, the model learns to identify the cases where it needs human help the most, dramatically improving efficiency and reducing annotations efforts and also the cost. So finally, we assessed how well the chatbot builds and maintains context, remembering details within a conversation, and also personal preferences across sessions, while still also protecting users' privacy. So at this point, we have explored nearly every dimension of evaluation, from foundational quality to the system's ability to grow and adapt. In the final session on Thursday, we will unify these elements into a complete evaluation framework and learn how to convert insights into polished reports and actionable improvement plans, bridging the gap between theoretical knowledge and also practical deployment. Thank you so much. Thank you for this session. Thank you for listening. Yeah, a lot of new knowledge. This is a heavy one and so theoretical. Welcome. Okay, so if anyone has a question, please go ahead. Okay, so does the model calculate confidence on its own, then forwards least confident queries to human feedback? Yeah. So we talked about different ways that it calculate the confidence. So one of them is that the model actually knows or try to know or try to evaluate if this answer is highly important for a human to answer for. So if it has multiple intents and it has a lot of like labels and it just froze and doesn't know how to answer it. So yeah, it then moves it to the human by itself. So yeah. Okay. Is it actually possible for a chatbot to learn safely in real time from every conversation using only automatic fact checking and filters with no human ever cleaning the data? So there is a supervision. There is a way or like a part where humans actually interact. We talked about it. It's called human in the loop. So if the chatbot doesn't know how to correct the data and doesn't know how to annotate the labels correctly, it then gives these these specific examples, not all of them, the highly important ones, the hard ones. It gives them to a human, someone that we actually pay for to annotate them correctly, and not just one person. It's like a committee of annotators that label the I'm sorry, they label the question or the intent correctly. So a human is a must over here. Did I understand your question? So, okay, thank you so much. Thank you so much. Okay, we've come to an end right now. Jesse, if you hear me, you can close the session.
Thank you, everybody. Have a good one.